Welcome to our channel. Today we're diving into the fascinating world of thermostats. You know, those little devices on the wall that somehow keep your house from turning into a sauna in the summer or an icebox in the winter. Ever wondered how they work? What kind of engineering wizardry goes on inside that plastic box? Well, you're in luck because today we're pulling back the curtain and taking a deep dive into the ingenious world of thermostats. We'll break down how these little marvels of modern technology sense temperature, make decisions and control your home's climate like tiny, silent HVAC conductors. Get ready to have your mind blown by the deceptively simple yet incredibly clever world of the humble thermostat. Let's dive in. First up, we've got to understand how a thermostat knows what the temperature even is, right? I mean, they don't have eyes. They can't just if it's hot or cold. That's where the temperature sensor comes in, the unsung hero of the thermostat operation. This tiny component is like the thermostat's own personal thermometer, constantly monitoring the surrounding air. Now, there are a few different ways these sensors can work, but the most common one uses a little gizmo called a thermistor. Think of a thermistor as a tiny resistor that changes its resistance based on temperature. It's like a magic resistor that can tell if it's getting hotter or colder based on how easily electricity flows through it. Pretty neat, huh? The thermostat then takes this information, this changing resistance value, and converts it into an actual temperature reading. It's like translating the language of electricity into something we humans can understand, like degrees Fahrenheit or Celsius. Another type of sensor uses something called a bimetallic strip. This strip is made up of two different metals, each with a different expansion rate when heated. So, as the temperature changes, one metal expands more than the other, causing the strip to bend. This bending action acts like a switch, triggering the thermostat to either turn on the heating or cooling system. It's like a tiny mechanical ballet, all orchestrated by the laws of physics. Now, these temperature sensors, they're constantly working 24/7, like tiny temperature detectives, gathering evidence and reporting back to the thermostat HQ. And based on this intel, the thermostat can then make its next move. But what happens with that temperature information? How does the thermostat know what to do with it? Well, that's where things get even more interesting. So, we've got our temperature reading thanks to our trusty sensor. But what happens next? How does the thermostat decide whether to crank up the heat or blast the AC? That's where the control circuit comes in, the brains of the whole operation. Think of the control circuit as the thermostat's internal logic board. It receives the temperature reading from the sensor and compares it to the set point, which is the temperature you've programmed the thermostat to maintain. If the sensor says the room is a chilly 65 degrees, but you've got the thermostat set to a cozy 72, the control circuit immediately springs into action. It knows there's a discrepancy, a temperature delta, and it's time to do something about it. It's like a little game of hot or cold, but instead of searching for hidden objects, the control circuit is constantly striving for temperature equilibrium, and it's surprisingly good at its job. Now, the control circuit can be a fairly simple on-off mechanism, or it can be incredibly sophisticated with advanced algorithms and logic to optimize energy efficiency. Some modern thermostats even learn your habits and preferences, adjusting the temperature automatically based on your schedule and behavior. It's like having a personal climate assistant, always working behind the scenes to keep you comfortable without you even having to lift a finger. But how does the control circuit actually control the heating and cooling system? Well, that's where our next key component comes in, the switch or relay. Okay, so the temperature sensor has done its detective work, the control circuit has crunched the numbers and made a decision. Now it's time to take action. And that's where our next component comes in, the switch or relay. This is the muscle of the thermostat operation. Think of the switch or relay as the middleman between the thermostat's brain, the control circuit, and the brawn of your heating and cooling system. It receives the signal from the control circuit and either opens or closes a circuit, just like flipping a light switch on or off. But instead of controlling a light bulb, this switch is responsible for turning on your furnace, boiler, air conditioner, or heat pump. Talk about a high-stakes job. Now, the switch itself can be a simple mechanical one, kind of like a tiny light switch inside your thermostat. Or in more modern systems, it might be a solid-state relay, which uses electronic components to control the flow of electricity without any moving parts. These solid-state relays are super quiet and incredibly reliable since there are no mechanical parts to wear out. They're like the silent ninjas of the thermostat world, efficiently doing their job without making a fuss. So, when the control circuit decides it's time to heat things up, it sends a signal to the relay, which then completes the circuit, sending power surging to your heating system. And just like that, your furnace roars to life, ready to battle back against the cold. And when it's time to cool down, same process, just in reverse. The control circuit signals the relay, which cuts off the power to the heating system and activates the cooling system instead. It's a beautifully choreographed dance of electricity and mechanics, all working in perfect harmony to keep your home at the perfect temperature. We've talked about the temperature sensor, the control circuit, and the switch relay. But what about you, the homeowner? How do you interact with this whole system, this intricate dance of temperature control? That's where the user interface comes in. The user interface is your command center, your control panel to comfort. It's the part of the thermostat you actually see and interact with, and it's come a long way over the years. Remember those old school thermostats with the mercury vials and the little clickety dials? You had to practically be a mechanical engineer to figure out how to set the temperature. Thankfully, things have gotten a lot more user-friendly. Modern thermostats often feature sleek touchscreens, intuitive menus, and even smartphone apps that let you control your home's temperature from anywhere in the world. It's like having a universal remote for your home's comfort right at your fingertips. Through the user interface, you can set your desired temperature, create custom schedules, switch between heating and cooling modes, and even monitor your energy usage. Some advanced thermostats even offer features like geofencing, which automatically adjusts the temperature based on your location. Imagine this. You're driving home from work, and as you approach your house, the thermostat senses your arrival through your phone's GPS and starts preheating or pre-cooling your home to your preferred temperature. By the time you walk through the door, you're greeted by a perfectly climate-controlled oasis, all thanks to the power of the user interface and the magic of modern technology. And that's how a thermostat works. From detecting the temperature to activating your heating or cooling system, these devices are essential for maintaining comfort in your home. Who knew so much ingenuity could be packed into such a small package? It's amazing to think that these little marvels of engineering are working tirelessly behind the scenes, constantly monitoring, adjusting, and fine-tuning your home's climate to keep you comfortable year-round. Don't forget to like, subscribe,